with the financial maths for grade 12, they're just adding more formulas. And the fortunate thing is the formulas that are being added are formulas that are on your formula sheet. Yeah, in addition to what you already know, you see. So for example, right, if you look at the formula sheet, right at the top, you're gonna have these formulas that you already know. There's the interest rate formula, the simple interest rate formula, right?
Yes.
And then here, this is like simple depreciation. Then you have the reducing balance. Then you have the compound interest formula. So that's the financial maths formulas that you know. So obviously after that, you have these two new financial maths formulas. These two new financial maths formulas, as you can see, they are on your formula sheet. So the good news is you don't need to struggle to what you might call to like remember them, you know, because funny enough, these are the kinds of formulas where as you start using them, they just stick, you know. So let's start with the F1, you know. So the F formula, right, says the F is equal to X 1 plus I to the power of N minus 1, like this. The whole thing is over I. So the good news is, right, if you look at N and I, those we already know. So let's start with what N and I is. So I and N are linked in a way, you see. The reason why I and N are linked is because of the following. So N, I always say N is always equal to years multiplied by, or let me just put it in words only first, and then I'll break it down later. So N in simple words is number of times interest is added. That's literally it. So as an example, right? An example is as follows. N is always the years multiplied by number of times interest is added yearly. So let me put that in words actually also, because if we can put it in words first, when the explanations come, it's easier. So in example, N is always the years multiplied by number of times interest is added yearly. So again, if I can add more to what is being said here, right? So you can see you have two things that I mentioned, right? Let me see here. Let me just do this. The two things that I mentioned, right? When it is in practice, you'll get a question where money is, for example, let's say here, example, interest compounded monthly. If your interest is compounded monthly, right?
Yeah.
Then N is equal to years times 12, you see.
Yeah.
If it is quarterly,
It's 4.
yes, N times 4. And then if you have no, am I saying N times 4? I meant years times 4. Years times 4, you see. If it is semi-yearly,
it's times 6 years.
Times 2, because it's every 6 months. So I see where your logic was when you said 6. It's for 6 months, and there's 2 sets of 6 months in a year. So semi, remember semi means half. It's just like a semicircle. So when you cut a circle in half, you get a semicircle. So let's see here. With all this being done, right? These are the main ones, you see.
Yeah.
So when I say these, the main ones, I'm basically trying to say that obviously, if they want to be all crazy, which is like super, super ridiculously rare, if they say something like, you know, weekly or daily, then you can use 52.
Oh, so you
Yeah,
can use
or
different
yeah,
days.
all depending on what they say, you see, because what they say can obviously differ from time to time. But the fortunate thing is the ones that we have just laid out now, these are more like the main ones, you see, if I can put it that way. These are more like the main ones, you see, because as long as you know these, then you are in a good spot. Okay, I'll just do this with this. With what we have just mentioned, right? These key pieces of information here, the 12, the 4, and the 2, it's exactly the same when you work out your interest, you see. So you see the same way we say it here, n is number of times interest is added, right? And here we also said n is just the years multiplied by the number of times interest is added yearly. So with your questions, they'll tell you these things, you know, compounded monthly, compounded quarterly, compounded semi-yearly. So what that does is it automatically alters the value of I, you see. So because remember, I is interest, you see. So with your interest, right, your value for interest, and this also actually goes for the value of I and N also. I mean, this goes for this F formula and the P1, you see, where I is, and where what you may call, where I is, and where N is. You see, where I is and where N is, you will always have to be careful what you put there. So for example, for interest, right, your interest will always be the value of I, which is, let's say they gave you 5% compounded monthly. Your value of interest will always be divided by the number of times interest is added yearly, you see. So let me actually add that. Let's see here. Number of times interest is added. Let me see here. Give me 2 seconds. Let me just actually copy these words. Number of times interest is added yearly. This part. That's what your interest will always be. Your interest will always be the interest value that they give you, right? Divided by the number of times interest is added yearly. So it looks a bit weird, but I think we will go through an example just now. Because, for example, let's actually write it down here. Example, if it's compounded monthly, right, then I will be over 12. If it is compounded quarterly, then I will be over 4. If it is compounded semi-yearly, for example, then I will be over 2. You see,
Okay.
whatever
Yeah.
the interest is. You
So
see,
it depends what they ask you for.
yes.
But if they don't tell you it's monthly, quarterly, or semi-yearly, you divide it by 100.
No. This is in addition to dividing by 100. You see.
Uh,
So, for example, if your interest is, let's actually add another column here, right? or another row. If it's, let's say, if it's 10%, then you're going to write down here 10% over 12, you see, meaning this is the same as 10 over 100, but because you also have to divide by the 12, you put the 12 down here like that, you see.
Okay.
If it was quarterly, let's say you'd have your 10%, right? You'd have your 20% divided by 4. You can either put it like this in your calculator, or you can write it like 10 over 100 times the 4 down there, you see. Because remember, 10% divided by 4, if you look at it nicely, 10%, right, is 10 over 100. So this divided by 4, remember, you're going to flip this over and then change this to a multiplication symbol, you see. And then you have your 10 over 100 times 4, you see. Yeah, so that's what you can always do. If you want to write it like this, you can. If you want to write it like this, you can. You can just remember to put the division symbol in your calculator, you see.
Yeah.
In addition to everything we've just said, right, this applies to, again, whether you're using the P formula or you're using the F formula, you see. It works just the same. So with that being said, right, let me do this. So if we're going to write out, or before we even move on, right, we mentioned what N is, we mentioned what I is. So obviously we have to mention what X is. So X is the monthly installment. So obviously, since this is like grade 12, this is what's new, monthly installment, or let's not say monthly installment actually, because that might not make sense if it's like compounded quarterly or semi-yearly or whatever. So X is your installment. Let's just call it that.
Okay.
Installment, because this installment could be paid monthly, could be paid what you may call, well, no, it's basically, let's just say an installment, you know, whether it's monthly or whatever, it doesn't matter. It's an installment, you see. So funny enough, what you may call, with that being said, right, we could have just said monthly installment here, but let's just say installment, so that it doesn't confuse you when they say stuff like compounded quarterly and semi-yearly. Let's just call it installment. So that's what X is. Because the idea with the F formula is that the main idea with this formula is it's called the future value annuities formula. You see, so let me actually write down the name here. Future value annuities formula. So the keyword in this statement is future, you see. So this is to tell you that this formula is used to find out how much money you will have in the future, literally. That's what the F is for.
Oh,
So
okay.
yeah, the way this works is you'll be making installments over a certain period of time. Maybe the money is compounded monthly, which is the usual one, at a certain interest rate. And then they'll ask you how much will you have in the account after, let's say, 5 years or 3 years or whatever, you see. So this question is, it's more like for when you make investments, you see. Investments, you see.
Yeah.
Yeah. So in addition to this, right, we mentioned that you have the P formula. The P formula looks like this. P is equal to X, 1 minus 1 plus I to the power of negative N. So with this P formula, again, so I'm actually going to just double check here to see if I wrote it correctly. And pardon?
Could it be past because the other one's future?
Funny enough, this is present. Present value annuities. You're close, you know, because with P and time, there's either past or present. So present value annuities. So what this is normally used for is to keep track of this kind of a formula. It's actually used for things like, loans and that kind of stuff. Like if you're paying off a loan, and the P will be, for example, or let's just do the rest first. You see, X is your installment, installment, and then I is obviously the interest, and then N is obviously, as we said, number of times interest is added, you see. Of times interest is added, you see. So the same way we said I, you have to divide by the number of times the interest is added yearly, and you have to multiply by the number of times interest is added yearly. Those same rules apply here as well, you see.
Yeah.
So you hardly ever put N as years, you hardly ever put I as over 100 only. Especially in grade 12, 99.99% of the time, your value of N, you're going to have to times by something. Your value of I, you're going to have to divide by something, you see. So that's the big idea with these two formulas. So in practice, right, you'll notice that the one thing I'll, for example, say, remember we said this one is for things like investments, right? So this one is mainly for things like loans, not only loans, but mainly loans. 99.99% of the time when this formula is used, you'll be like paying off a loan, right? So for example, P will be present value. Let's just say present value. Now, what present value refers to is, for example, if in a question, right, P will be amount that you borrowed, X will be the amount you'll be paying off monthly to pay it off, and then interest is how much interest is added as long as you still have the debt, and then N is how many payments you need to make for you to finish paying off what you owe, you see.
Yeah.
So that's what P is. That's why P is present value, because it's a value that actually exists right now. You see, say if you borrow like 500,000, it's money you already have right now, you see. So with F, it's different because it's money that you're going to get after the time period has passed, you see.
Yeah.
Yeah. So with all this that we have been saying, right, what is important is to also remember that with your financial math, your formulas will always, depending on what questions they ask, right, you'll have combinations of these formulas. For example, without us going into actual questions, right, we also have a scenario where they'll ask you for the outstanding balance on a loan, because I'm trying to just lay out the different kinds of formulas that you need. Outstanding balance on loan. So the balance on a loan, let's say here balance, will always be equal to the A formula minus the F formula, you see, of which the A formula here is the compound interest formula, and then the F is the future value annuities formula. And I'll explain the logic behind this just now. So the idea with this balance formula is that when you take out a loan, A is representing the loan value increasing and gaining interest. F is representing all the installments that you will be paying on a monthly basis, you see. Because remember, with loans, right, the interest that is added onto your money is based on what you owe at the present time when, let's say, the month ends. Say you borrow like 100,000, right? If let's say you pay off 10,000, you're going to owe 90,000. So they're going to add interest to 90,000, you see. And then once they add interest to 90,000, when the new month comes, you pay off some more money. And then whatever is left, they add interest to that, you see, going on and on and on. They'll always add interest to whatever you currently owe after you pay your what you call your premium, you see. So with that kind of a setup, right, this is where your balance formula comes in, because this is saying that the interest on the loan is going up, but then at the same time you're paying it off, you see. So depending on when they want you to work out the outstanding balance, they can say work out the outstanding balance after 4 months, after 5 months, after 3 years. Let's say the loan period is like 10 years, right? They can ask for the outstanding balance after like 3 years or 5 years of you paying off the loan, you see. This is your formula. Your formula will just take into account, okay, what money do you borrow and what's the interest rate and how many months have passed. This will be saying how much are you paying every month, or how much are you paying as an installment. And then this will be telling you how many times that money has been paid and what the interest is, you see. So it'll be basically two separate calculations. One, here you get an answer, here you get an answer, and then you just say A minus F, you see.
Okay.
However, yeah, however, there is a different way to work out the outstanding balance on the loan. The other way to work out the outstanding balance on the loan is to use the P formula, you see. So what I want to showcase is, if you look at something like the financial maths playlist, the financial maths playlist basically lays out everything that we're talking about right now in a much more swift and better way, in my opinion. So for example, if you see here, financial maths grade 12 outstanding balance, there are two ways to get the outstanding balance. The first way is what we have just mentioned now, and then the second way I'll just show it to you right now, because it makes use of the P formula. See, so let me just skip this thing. So if you look nicely here, right, let me actually do this, go to the front here. So if you look nicely, option 1 is when you have, option 2 is what we just showcased now. You see, when you have the number of payments that have already been made. So if they tell you have made payments over 2 years and your loan is like a 5-year loan or whatever, then all you do is the 2, you'll multiply it. Let's say if it's compounded monthly, it's going to be 2 times 12, which is like 24 times, because those will be the number of payments made. And then you use this formula A minus F. Option 1, to get the balance, all you need is the number of payments that are left, you see. So meaning, let's say you have to make 240 payments in total, but you have paid, let's say, 120 times already. Then all you use is option, this other option here, where your balance is technically balance. It's technically the P formula, x 1 minus 1 plus I to the power of negative n. But obviously here n is the number of payments that are left. Number of payments still to be made. Let me write this a bit better here. Well, I don't know why I zoomed in so much. So number of payments still to be made. So let me not use 120, because that's like half of this. So let's say you have 240 total payments to make, right? But then say you made 60 payments. 60 payments made. You see, it means that your value of n will be equal to 240 minus 60, which is like 180. You see, so your n will be like 180, because n is the number of payments still to be made. You see, so if your total payments, you need to make 240 of them. If you had already made 60 payments, then for you to use this formula to get the balance, you will just use n as 100. and 80. You see, two options to do the exact same thing.
Okay,
You see,
that's good.
yeah. So in addition to your formulas, right, you have one other thing that you normally need to work out, right, and that's referred to as the final payment on a loan. So explaining the logic behind the final payment on a loan, this is the logic behind it. Let's label here final payment on loan. So when you work out the final payment on a loan, this is the idea. Say you bought something, right? And you're paying it off monthly. But say your monthly installment is like 1,500. Let's say for example here, an example, installment, let's make it 1,500, right? So you're paying this 1,500, like let's say monthly, you see. So say you owed some amount. We won't necessarily mention an amount right now, but let's just think of a random number, right? Say you owed, let's say owed 10,000. If you owed 10,000, right? Obviously, if you're going to be paying, let's say 1,500 every month, you can imagine as long as you're going to be paying 1,500 every month to pay this off, even if this is going to be gaining interest, it doesn't matter, because your very last payment, there's no guarantee that it's going to be exactly 1,500, because when you pay 1,500 here, you will be owing 8,500, and then if they add interest to it, who knows, it might go to like 8,600. And then when you now pay your 1,500 again, the money keeps dropping until your balance is, let's say, maybe 900 rand. You see, so obviously, when your last payment is to be made, you won't be paying 1,500. You will only be paying 900. Does that make sense?
Yeah.
Yeah. So that's what final payment on a loan refers to. It refers to the fact that your final payment on a loan will not be your full installment. You see, it'll be something less, you know. So with that being said, right, the formula that we are going to show, it looks a bit long, but it's all that you need to know when you work out the final payment on a loan. So let me actually just skip to this. You see, the final payment, this is all you need to remember. You see, it's A minus F, and then you have 1 plus I. You see, so when you think of formulas like that, you know, it helps you to not always visualize them as something long. You see, so final payment, let's say here, final payment is always equal to technically the balance of the loan and then 1 plus I. So this is literally saying, obviously, if you were paying it off over like, I don't know, like 15 months or something, this will be giving you the balance after 15 months, you see, or rather after 14 months. And then having to have had the balance after like 14 months, this is telling you that one more interest is going to be added at least one more time. And then whatever that value is, that's what you have to pay. I'll repeat, this will be telling you the balance at the very end of your installment period. And then they're going to add interest to it once, and then whatever is left, that's what you have to pay, you see. So if you look nicely here, right, if you see here, final payment is just the A formula there, the F formula there, then 1 plus I over there, you see. So your value of N is obviously always going to be a whole number. To better explain this also, your N, let me say here, obviously N is going to be a whole number. Now, the reason why I'm saying N is a whole number is, if you can recall, right, when you work with when you work with financial maths, you have to remember there are times when you will, let's say, be asked how many times is let's say they'll sometimes ask you things like, how long will it take to pay off the loan? And then let's say your answer comes out as like 30.3. You see, this is telling you that it's gonna take a complete 30 months, but then in the 31st month, that's when actually the loan is going to be paid off. Because remember, your calculator won't necessarily give you a whole number for those kinds of questions, you see. So in this kind of a situation, if your N, when you were working out how long it's going to take to pay off the loan, is like 30.3, your N in your calculation will be at 30. You see, you'll put your N as 30 in these calculations, and then the 0.3 is represented by this part when interest is added at least one more time, you see, because this is saying that after the 30 months, you're still going to owe something, you see. But then during the 31st month, that's when interest is obviously going to be added once, and then you just have to pay that off, and then you're good to go. Does that make sense?
Yes, it does.
Fantastic. So you see, before I blab a bit too much, this is one thing I can safely say, right? Because it's just logically more sound. You see, because if you look at how short these are, it's like 7 minutes, 4, 4, 3, more like 4 minutes, 5 minutes, 3 minutes, 2.5, 6, 5, 5, 7. This playlist is what's needed to like jumpstart you into the financial maths era, you see. Because if you think of it, this is going to give you the revision that you need. This is going to give you another breakdown of the future value annuities formula. And then this is going to explain X and N. And then
Are
here,
the timelines asked often?
not necessarily. It's just something that you need to be able to work with, you see.
Okay.
Yeah, of which we're going to work with different examples on timelines when we do start with timelines.
Okay.
Yeah, so let me just stop this one here. So that's what I